Okay, what is the radical form of this expression here? Well, notice that is the same thing, and we did these before. The A is what's going to go in the house, in our radicand house. A is going to go in the house, remember? And then 3 indicates that's what we're the root we're looking for, so it's got to go right here. 3 is going there. And then the 4 is taking it to the 4th power, so that would be our answer right there. That's all we have to do on that. All right? We have to know where those particular numbers go to. So, what is the value of this one? Well, first off, the 5th root, we're looking for the 5th root, so I'm going to go here. See, the 5th root there is 32, 243. Oh, look, 1,024. I see a 5/5 root right there, 5,024. So, I know it's right, correct that one right there. So what I'm going to do is this. So the 5th root of 1,024 is 4, but because it's a negative, we know it's then what? Negative 4, because we can have that, that's an odd number right here. And then we're going to multiply that negative 4 to the 3rd power. So it's negative 4 to the 3rd power, which makes negative 64. Negative 64. All right. Also, you could use the force loop by using the calculator. And to do that, go to your calculator, go to the Add Calculator feature, type in your negative 1,024, hit your exponent button right here, and then in the exponent part, you'll put that 3/5, and it will tell you the answer is negative 64. All right, now we're going to simplify this one right here. You're going to say a simple Simon. So here's what we're going to do. How do you do these here when you have one in the numerator, denominator? If you go back to your law of exponents, all the rules there, see it pop up. I think we want to look at this law 2 right here. So, I guess I haven't. Okay, law 2. And we're going to subtract it. So I have 4/3 minus 2/7. So to subtract those, you need a common denominator, which will be 21, because 3 times 7 is 21. So I'm going to take the top one times 7 each, which makes 21 over 21. I'm going to take the bottom one times 3 each, numerator and denominator, which will make this here, so that when I subtract the 28 minus 6 is 22 over 21. So your answer is A to the 22 over 21 1st power. All right. And then this one here, if x and y are positive real numbers, write the equivalent expression. Well, this is a square root. So what's the square root of 49? I'm going to square root each of these. The square root of 49 is 7. X to the 8. You divide, so take the exponent divided by 2, so it's x to the 4th. And here I'm going to take this 10 and divide it by 2, so it's y to the 5th. So that is the equivalent expression, provided that they're all positive. And then here we go, an algebraic expression below. So we're going to rewrite this involving our integrals. So here's what happens. I'm going to basically square root this and take it all to the 5th power. So let's square root each of these things individually, kind of like I did the last thing. The square root of 4 is 2. The square root of x to the 4th, you're dividing by that 2, 4 by 2. I'm going to divide 10 by 2. And I'm going to divide 8 by 2, my exponent. Now I'm going to take each of these to the what? 5th power. So it's like exponent right here, this law 6. Okay, so here we go. So that's going to be 2 times, oh, I made a mistake on this one. So yeah, we'll correct it right here visually. All right, this is not 2 times 2. It's easy to make a mistake. It's actually 2 times 5. So we'll stay up here and just correct. That one is still 5 times 5. It's 2 to the 5th and 4 times 5. So I know my x is going to be wrong, so we'll just correct it right here. It's not going to be x to the 4th, but what's 2 times 5? It's x to the 10th. That's going to be the 10th. All right? And we have y to the 25th. 2 to the 5th is 32, and then z to the 20th. Like I said, it's x to the 10th, y to the 25th. So sorry about that. But it just goes to show you everybody makes mistakes. It's very easy to do. All right? Very, very easy to do the following. So that would be our simplified algebraic expression.